Hello YouTube, welcome to this video. We're here again with the analyzing mechanical effects of a temperature rise on a power PCB. So I will bring in static structural analysis module over here, and then I'll drag and drop the geometry cells, and I need to connect the solution of the Fluent to the setup of the static structural. Before going to meshing and modeling, we need to define our materials. So right click on engineering data and click edit. Then click here to add a new material. So we need to name it copper. Okay. And then we need to drag and drop isotropic thermal expansion and isotropic elasticity, Okay, so here for the coefficient of thermal expansion, we will specify 1.77 e2 minus 5, and then for the Young's modulus, we're gonna say 1.2 e2 plus 10, and then for the Poisson's ratio, we're gonna specify 0.38. Okay, then we need to add another material for the PCB board, FR4, and then we need to include isotropic thermal expansion and isotropic elasticity. And for the coefficient of thermal expansion, we need to specify 1.5 e2 minus 5, and for Young's modulus 2.4 e2 plus 10, and for the Poisson's ratio it's going to be 0.136. Okay, now we can close our engineering data. Then we can start meshing and modeling our simulation in the ANSYS Mechanical. So here in the model we need to suppress the air chamber because we don't need the air chamber over here. Okay, then here is our PCB. So for the material we will change it to FR4, and then we right click and hide body. Then here, so everything else is copper. So we'll change the rest of the parts to be copper. Okay. So we can see that everything is copper except the board. Okay. So then let's see. So if I show this body to see my board and everything. So, and if I generate the default mesh to see how much accurate is the default settings. Okay, it seems that we need to insert some sizings. Okay, so we'll select this one, apply, and let's say for A-3 and height body, and another sizing, and select box, select everything else and apply, and then for the element size we will say 3E-3, and then for here the sizing. Okay, let's see what this mesh will give us. So we can see that meshing is completed and mesh is accurate enough. So I can right click over here and select show all bodies. So our mesh is good. Then we need to go here and right click. So we need to here to specify some fixed points over here. So we'll select single select, and you'll select these faces, these terminals. These 6 faces are fixed points. Then we need to go over here and import body temperature from ANSYS Fluent. So it says we didn't specify which body to apply, so we'll select everything and click apply. Okay, not faces, bodies. Apply geometry and right click import load. So it will start importing the load from ANSYS Fluent. So you can see that it has imported the temperature. Then we can go and for the solution, right click and insert deformation, a total deformation for all bodies, and then we can right click and click solve to start simulating the deformation of the board because of the temperature rise. Okay, the simulation is finished, so you can see that the board deformation, here is the board deformation over here, and so if we go to results, this is like scaled up. The deformation is scaled up so that we can see. If we select true scale, The deformation is not that crucial, but you need to consider these deformations in these high-tech applications. So I'll select auto scale, and you can see if it is too high for the board to withstand, will the board crack or not. So we also can create an animation of the deformation, and also we can save the output file. So you can see that here, you can see the deformation of the board. How it is happening. And if you stop it, and you can click export video file, and then you can specify where to save the file, and it will give you a file with the animation of the deformation. So I think that is everything for this simulation. If we go back to the ANSYS workbench, this is the workflow one that we completed the analysis by importing the board 3D file from Altium Designer to the ANSYS geometry, then using that geometry in all of the three modules. And we used ANSYS Maxwell to extract losses, and then we used that losses as a heat source in the ANSYS Fluent, and then we got the temperature from the CFD analysis, and then we used that body temperature of the PCB to study the deformation of the board because of the temperature rise. So that is everything for workflow 1. We will talk about workflow 2 in the next videos. So to the next video, take care, bye.